Thank you very much for the introduction, Prof. Yeah, so my name is Lucas Hermans, and as discussed, I'm just going to talk to you about several aspects of my PhD program project that I performed in Gauteng and Limpopo as it relates to drug level testing. And the title of the talk is Drug Level Testing as a Different Approach, or maybe a novel approach to HIV treatment monitoring. So the contents of my presentation, I'll just start to talk about HIV treatment in South Africa and just give you a brief introduction. Then talk about a few of the obstacles in achieving the very high virological suppression targets that are set by the global community. Then look at, with the transition to dolutegravir, what impact this has on existing HIV treatment monitoring algorithms. And then in the end, discuss drug exposure testing as a potentially novel way of monitoring for success of HIV treatment. So HIV treatment in South Africa, just in a nutshell, in the whole of sub-Saharan Africa, there's currently plus minus 25.6 million estimated people living with HIV. Of those, a very high proportion, 7.7 million estimate, reside in South Africa. I think South Africa is a beacon of success when it comes to the treatment coverage rates, which even though the population of patients with HIV is expanding, so is the treatment coverage rate, which now stands at around 71% of adults in South Africa. But much work needs to be done there. And of note, it's also the treatment coverage rate is also far lower for children. So there's still several problems there. In the current, as it stands currently, the country is transitioning, like most low and middle income countries, from an efavirenz-based first-line regimen to a dolutegravir-based first-line regimen. So the global community, and this is basically driven by UNAIDS, has set ambitious goals for the eventual control of the HIV epidemic through treatment. Those goals were initially known as the 90-90-90 by 2020 targets. Obviously, 2020 has since passed, a lot has happened, and these targets have been updated to the 95-95-95 targets, you will well be aware, which were initially set for 2030, but have now been adjusted to needing to be met by 2025, I read recently. For my topic, my main interest was basically the virological suppression target of 95%. So basically the last of the three targets in the cascade. And I think this is something that we often forget working in high resource, relatively high resource settings in the South African context, but the majority of patients in South Africa receives treatment under very challenging circumstances in an overburdened health system, challenged by long waiting times, long travel times to and from clinics, and few staff. And then the recent COVID pandemic and associated lockdowns has had additional negative impact on people's ability to attend clinic and take treatment. And this has also been borne out of recent studies. I'm just going to transverse now to talk about obstacles in achieving the 95% suppression target. So it's very important to get a good hold of what are we measuring when we measure virological suppression. Most suppression rates reported in literature stem from single center cohorts. The problem with those is that there might obviously be some publication bias when an individual center publishes their virological suppression rate. And those rates are likely not representative of under-researched sites. Now, the way organizations like UNAIDS often deal with this is by sourcing nationwide laboratory data to increase their coverage of the total population on treatment. And although that helps, those data are often difficult to correlate with the actual situation on the ground and clinical data, and might therefore also be inaccurate. And fortunately, recent sort of advances in how we analyze big data may sort of bridge this gap and give us a more fair overview of virological suppression rates in a large community. And we performed one of many studies that is now being done with big data in the South African cohort. In our study, and this is a collaborative project with Ezincha, my university in Utrecht, and the National Health Laboratory Service, we included patients from 52 clinics in Mpumalanga, Limpopo, Gauteng province, and Northwest province. And we sourced clinical data from the tier.net database, which is the national database that the Department of Health uses to record clinical data related to HIV treatment. Because laboratory data is often missing from that system, we then cross-matched laboratory data from the National Health Laboratory Service database with that tier.net database to get a more complete overview of our patients. And these are basically the results. So out of almost 200,000 records of patients with a documented ART start date at these clinics, we included a little over 100,000 patients, 102,000 of those on first-line ART. Of note, this was performed in the efavirenz era, so 98% of these patients were actually on efavirenz-based first line. And we wanted to kind of give an overview of their success rates in the graph that you see on the right. Basically, you can obviously see the different colors, and all the colors obviously mean something. So I'm now going to go through them in turn. The dark gray column is a big problem. These are the patients who have become lost to follow-up. And as you can see, the population of patients becoming lost to follow-up is actually on the increase the longer you treat. And in another review, loss to follow-up rates have reached up to 40% after 6 years in the African region. And you can imagine that if we talk about wanting to achieve 95% virological suppression, then you need to see that as an intention to treat kind of targets. And if we lose 40% of patients to follow-up, then we'll never reach such percentages. The good news is, though, that not all these patients who are lost to follow-up are likely to be completely lost. We know that unfortunately a large proportion of them dies, and that about 30% stop treatment altogether. But there's also a percentage of patients that self-transfer, silently transfer back into care elsewhere. And there's another proportion of patients depicted by the orange band here, and those are patients with low-level viremia. You can see that roughly 10% of patients over time have a low-level viremic viral load result. These patients don't pose as much of a direct concern from the transmission point of view, because transmission during low-level viremia is probably very rare to non-existent. However, we know that low-level viremia correlates very nicely with poor adherence and puts patients at an increased risk of virological failure later on. So as you can see from this graph, roughly 50% of the total population is completely suppressed, visible in the green. But of that population, a certain percentage will develop low-level viremia, and that population will be of increased risk of failure later on. And the actual concern that we're dealing with is the red band in the graph, which are patients who had a last viral load of above 1,000 copies while on treatment. And that band is approximately 10% of all patients at any point in time. There's obviously risks associated with viremia. It can deteriorate patient health. And importantly, it also allows for onward transmission from HIV. And one of the concerning aspects in this study is that we found that even though we followed patients for 6 years in the study, we saw that the proportion of patients with a viral load above 1,000 stayed almost constant over time, which means that even though you treat patients for long-term, there will always be a population of patients on treatment that are still viremic, not appropriately suppressed, and able to transmit their HIV onward. And that, again, is a big threat to a success of treatment programs. And this population of patients, or the population of patients with a viral load of above 1,000 on ART, those are actually the patients that I will focus on for the remainder of my presentation. One of the big questions that we had is why this population of patients stays constant. Because if you think about it, we have guidelines that tell us what to do if a patient has a viral load above 1,000. If that happens, in the efavirenz era, we need to apply adherence counseling, then repeat a viral load within 2 to 3 months. If that viral load is then suppressed, we can continue the current regimen, and the patient will no longer be at risk. But if the viral load is then still increased, the patient is supposed to be switched to an appropriate second-line treatment regimen. And if you think about it, the fact that so many patients stay viremic over time kind of suggests that this is not really happening in practice. And when we looked into this in the same study, we found that indeed the observed practice in this large treatment cohort differs from what the guidelines recommend. If we look at the overall population in this cohort that had a viral load of above 1,000, then at the next viral load measurement, just under half of patients resuppress, and that is obviously good news. Those patients are no longer at risk and can continue first-line ART. However, over half of all patients had confirmed virological failure. And even though we expected to find these patients being switched rapidly thereafter to a second-line regimen, we found that despite of the long follow-up in our study, the majority of patients were actually not switched and remained on first-line ART in the face of virological failure. And only 41.5% of patients were switched. More alarmingly, perhaps, is that the patients who were switched after significant delay. This is a figure from the paper, which is published in PLOS Med in 2020, where we compared the ideal scenario where you have a patient with virological rebound on time point 0. That patient would then be followed up and a repeat viral load would then be done somewhere between 8 and 12 weeks. And if that repeat viral load would still be high, then the patient could be switched even the following month to a second-line regimen and then re-achieve virological suppression. But what we found in this study is that in practice, after first detection of viremia, the repeat viral load to confirm the viremia was often only done after half a year. And then if that viral load was found to be high, no immediate action was taken in most cases, and the viral load was repeated several times thereafter. And of the minority of patients who were in the end switched to second-line ART, that switch only occurred after a median 68 weeks, so almost 1.5 years after detection of viral rebound. And you can imagine that in this population kind of creates a very large pool of patients who are viremic for a long amount of time before their viremia is finally addressed. So one question is obviously if these findings that we made, namely that switching was so often absent and delayed, if that could maybe be a consequence of the data that we use, because that was a big concern that we had. Maybe a big data cohort just misses certain things, and that's why we had such a low switch rate. But we actually compared those results that we found with other recent studies performed in different areas that all have very similar findings. A recent study from KwaZulu-Natal showed that only 34.6% of patients with a failure of efavirenz-based ART were switched to second-line ART, and that switch took approximately a year from first detection of failure. In a study performed in Swaziland, figures were very similar to KwaZulu-Natal, and in a study performed by Médecins Sans Frontières Mozambique, the amount of confirmed failure cases switched was even lower at 31.2%, and they did not report the duration of switch. So what are the consequences of delayed switching? I already alluded to this, obviously, but it's just important to, I think, get this right. From a patient perspective, staying on a regimen in the face of failure can result in a CD4 decline and clinical deterioration and disease. And if resistance mutations are already selected at an early time point, not switching patients in time will only allow for further resistance mutations to the regimen to accumulate. From a public health perspective, these patients pose a big threat to onward transmission. And if they have resistant virus by the time they transmit, then that can result in the potential for transmitted drug resistance as well. So what we were very interested in is to figure out what the reasons are for this severely prolonged switch. And unfortunately, this slide is very boring because the research into underlying reasons for this hesitancy and delay is very, very, very limited. From the limited things that I've been able to find, several different factors are proposed, primarily, obviously, patient factors. such as patient non-attendance or patients' inability to tolerate certain drugs. But in other studies, and this is often the case in studies performed in other African countries, several important infrastructural barriers are also mentioned. Viral load measurements are often not done or the result not checked. Second-line drugs are often unavailable, which means that you can't switch to them. And in some healthcare workers, lack of knowledge on when and how to switch is sometimes lacking. But what we also found is that there's a significant amount of reasons being proposed that actually relate to healthcare worker hesitancy to switch. Many healthcare workers report that when they are encountered with a patient who's viremic, they start by having doubts about the patient's adherence. They worry that if the patient already has side effects to the first line, that those side effects will only be exacerbated when switching to second line ART. And then there's also this hesitancy that relates to the fact that people are worried that if they start second line too quickly, and that if patients fail a second line, that at some point no other agents will be left. I would like to now kind of continue to the next point. Obviously, this research was all done in the era of efavirenz, and as we've now progressed to the era of dolutegravir treatment in first line, I want to talk to you about how the face of HIV treatment monitoring is changing in this new era. I think it's just important to just reiterate that any clinician who is sort of faced with the decision whether or not to switch is kind of performing a balance act, where you're always thinking, is the problem that I'm facing due to underlying drug resistance or solely due to non-adherence? And I think it's just important to note conceptually, this is research by David Banksburg performed very long ago, that the sort of paradigm of drug resistance versus non-adherence is sort of a false paradigm, because we know that patients select drug resistance during episodes of relative non-adherence. And that therefore you can't really speak about drug resistance versus non-adherence because the two often go hand in hand. The question that we're actually asking is, does our patient have drug resistance, or is the viremia solely caused by non-adherence in our patient? And what's very important, and that's also been shown by David Banksburg, is that the rate at which drug resistance gets selected varies greatly depending on the regimen, which is why when we perform this balancing act, we obviously think differently about resistance depending on what regimen patient is on. And this has been informed by data. In the old era, when patients were treated by efavirenz, we could be fairly sure that if a patient is viremic, that drug resistance to the regimen is present. In this just tabulation of several surveys of patients on efavirenz-based ART in the African region, the prevalence of resistance to efavirenz was over 80% upon detection of failure in most cases. However, when we then talk about boosted PIs, the landscape changes considerably. And in fact, in the early prevalence studies of drug resistance in patients failing a lopinavir-based treatment, a major PI drug resistance was very much absent. And this has been shown by a recent review by Stockdale et al. And CID, is that PI resistance actually only accumulates over a long period of time. And when they looked at surveys of PI drug resistance in patients failing PI-based treatment, in cohorts that were only treated for under a year, PI drug resistance is basically absent. And only as cohort follow-up durations expanded did we start to see the PI resistance emerge. But even with that, the emergence of PI drug resistance is relatively slow. And in current surveys, we think that PI drug resistance is present in about 20 to 25% of all cases of patients with long-term failure of lopinavir or other PIs. And this is important because whereas for NNRTIs, the high prevalence of drug resistance made it easy for us to decide to switch to another regimen empirically, the low prevalence of drug resistance to PI-based ART rules out any benefit of an empiric switch. Now, the new kid on the block is obviously dolutegravir, and the dolutegravir situation as it relates to drug resistance during failure is very different, and as far as we know, relatively unexplored. Treatment emergent INSTI resistance remains very rare in patients who are naive to treatment and fail DTG. There had been no cases of resistance observed in the registration trials for dolutegravir, and subsequent cases have been limited to case reports only. And the first case report actually appeared in NEJM in 2019, which I think is a marker of how incredibly rare that event was. However, when we look at patients who fail second-line treatment containing DTG, the story becomes different. In the Dawning trial, which was performed several years ago, where dolutegravir-based treatment was compared to lopinavir-based treatment in second-line ART, showed that although dolutegravir performed better from a virological suppression when compared to lopinavir, in patients who failed dolutegravir-based treatment, and there were 11 patients in the trial, 2 patients developed treatment-emergent INSTI resistance, or 18%. In the more recent published NADIA trial, which was performed in African countries, the prevalence was very similar, but the numerator was slightly bigger. In clinical practice in low and middle income countries, however, we haven't really started that many patients on second-line DTG and followed them up from a long term. So I think the number is still out there. But we do have some recent early experiences from Botswana. This is data published by Seattle et al. In Viruses in 2021. Botswana was basically the first African country to roll out dolutegravir at scale. And they now report several cases of treatment-emergent INSTI resistance in INSTI-naive individuals on dolutegravir in their setting. So I'm just going to go back a little bit. We performed another study looking at drug resistance to PI-based ART because we were kind of interested in seeing where the prevalence of PI-based PI drug resistance is sitting now in the South African treatment program shortly before rollout of dolutegravir. So what we did for this study, it was a retrospective study where we sourced data from the public HIV treatment program, again in 4 provinces, Gauteng, Limpopo, Mpumalanga, and Northwest. And we included 544 adult patients. These patients all had virological failure with multiple viral loads above 1,000 copies per mil. They were all on second-line lopinavir-based ART. And for all of these patients, long-term failure was present and drug resistance testing with the NHLS was requested by the clinician. And as you can see on the table on the right, the majority of our population was female. They were 41 years on average with a median log HIV viral load of 4.9. And most patients were on lopinavir combined with an AZT3/TC backbone. What we found in this study is that major PI drug resistance, and this was defined as the presence of either one IAS major mutation or a Stanford score of over 15, was only present in 25.4% in all cases, meaning that 3/4 of patients with long-term PI failure, again, in accordance with earlier surveys, did not harbor any meaningful resistance to the PI. What we also found in this study, however, and this is what we found very interesting, is that the M184V mutation, which confers drug resistance to lamivudine and emtricitabine, was only present in about 2/3 of all patients. And this is interesting because it is an indicator of very poor adherence in the remaining 1/3 of patients who did not have that mutation detectable. And that is because, and that is shown by Devereaux et al. In the very early days of the rollout of ART in high-income countries, in studies where patients were started on treatment and developed drug resistance and then were then stopped, the M184V mutation, because it hampers viral fitness, actually reverts back to wild type. And these authors fairly nicely demonstrated that this reversion takes place from about 4 weeks to 3 months. Which means that the patients in our study, if you would translate it back to that data, were basically not taking much treatment for about 4 weeks to 3 months, which is obviously concerning. It is concerning because from from firstly, drug resistance testing is very expensive, and it is obviously futile to request drug resistance testing in patients who are demonstratively non-adherent. The number needed to test with drug resistance testing in order to find one case of drug resistance to the PI was 4. That number is actually aggravated by the fact that the reliability of population-based drug resistance testing actually becomes worse if patients are poorly adherent, because as I expressed before, mutations tend to revert if you're not adherent to your ART, which means that even though we might find wild type virus on the drug resistance test, you might have some amount of drug resistance in the background that we cannot see. And this translates in a problem that we think will translate into how we go about managing failure in the dolutegravir era. The current South African guidelines state that if a patient is on PI-based or INSTI-based ART, that in case of failure that we need to perform resistance testing, but that we can only perform resistance testing if we have at least 3 viral loads of above 1,000 consecutively, and if our patient is on that regimen for at least 2 years, and if we have addressed any obvious adherence issues. The guidelines then state that we should send these patients off for population-based drug resistance testing. However, as I said before, the yield is already low, only 1 in 4, if we talk about picking up actual meaningful drug resistance in the case of lopinavir-based treatment. We don't yet know, but it is very likely that this yield is probably even going to be lower in the case of dolutegravir-based ART. To aggravate matters, drug resistance testing is not universally available in Africa. South Africa is blessed with the drug resistance testing program and a third-line program, but that is not rolled out in many African countries. And then my other concern is that if we do this, then basically what we do is we keep patients viremic for a long term and unaddressed while waiting for them to become eligible for a drug resistance test before we can actually address their issues related to their viremia. So this brings me to the last point of my presentation, and that is that I want to introduce drug exposure testing as an alternate means of following up these patients and figuring out what is wrong. So how about drug level or drug exposure testing? And my basic question is that if current drug resistance testing, as seen from the previous study, is mainly picking up on patient non-adherence, but not finding many cases of actual drug resistance, then why don't we just measure drug adherence to drug first? We already know from several studies all performed in the Western Cape that poor adherence to ART is correlated with the absence of resistance in patients on lopinavir. And this is demonstrated using pharmacy refill data, random plasma levels of lopinavir, and also lopinavir hair levels, which give you more of a marker of long-term adherence. But correlation doesn't automatically imply good diagnostic performance. So what we set out to do is to ask ourselves if drug level or exposure testing could be used to predict drug resistance testing in patients failing ART. So what we did is that we actually went back to our survey of patients who failed second-line lopinavir-based ART that I discussed just now. And on the sample that was sent for drug resistance testing at NHLS, we went back to that sample and performed the lopinavir level measurement on the same sample. We used liquid chromatography coupled mass spectrometry to do this. And we used plasma samples in 494 cases. And in the remainder of patients, we used DBS samples that were also used for the genotyping. We chose to report the results not as a number because we were not interested in the actual level, but rather as detected or not detected at a very low threshold. Basically, what we did is we call this exposure testing. We kind of followed like a protocol as how you would for testing of drugs or abuse. You are only interested to see if you can detect any lopinavir in the patient without any regard for the therapeutic window of lopinavir. So what we found in the same group of patients is that in all these patients who were failing lopinavir and for whom samples were sent for drug resistance testing, almost half of patients did not have any detectable lopinavir in their plasma. That is obviously interesting. But when we correlated the levels to PI resistance, we found something that we feel is much more interesting, namely that this negative lopinavir level was actually very diagnostic. What we found is that in patients with negative lopinavir levels, only 5.9% had PI resistance. Whereas in patients with a positive lopinavir level, PI resistance was present in 45% of cases, basically showing that the patient's pre-test probability, which is 25% in this study, was drastically altered when you take the negative lopinavir level into account. The resulting sensitivity and negative predictive value of these of lopinavir level testing for lopinavir drug resistance were very good, 90 and 95%, and led us to conclude that a negative lopinavir level could be used to rule out out resistance to lopinavir to a high degree of certainty. And of importance in patients with whether we sampled plasma or DBS didn't really matter. The test performed equally for both sample types. Now, the following question we asked is basically if this new methodology of drug exposure testing could actually be of clinical benefit, because even though this one study we performed was promising, there isn't actually much data on this. Only one other study performed by Richard Poort et al. And published in 2016, performed in Cape Town, showed somewhat similar results in a smaller data set. Some other studies are currently ongoing, but we do not yet have much data on this. Another problem is that the methods that we used in this study are fairly expensive and definitely not available across low and middle income countries. And then the most important question is, could we extrapolate this data that we gathered on patients failing lopinavir to future patients failing dolutegravir? So now I'm just going to talk about some projects that we are doing to kind of explore possibilities to use drug level testing in practice and to see how it could be useful clinically. In this study, we tried to kind of design ways to make drug level testing much cheaper and much easier to perform. This study was performed in collaboration with an American company, ARC Diagnostics Incorporated, who did not provide funding, but did provide the kits for our study. And this company has developed several immunoassays that can be performed on plasma for the detection of various antiretroviral compounds. And the compounds that we were interested in were efavirenz, dolutegravir, and lopinavir. We set out to use these immunoassays and implement them in a resource-limited setting. And we chose to implement them at the Ndlovu Care Group Clinic in rural Limpopo. You might know Ndlovu Care Group from the Ndlovu Youth Choir, who amazingly broke through on American Got Talent several years ago and are now very famous. And that youth choir is actually sort of from the same NGO as the one that we performed our study in. The clinic actually consists of a large HIV clinic with a local laboratory where basic testing is done. And these immunoassays were implemented on a standard issue chemistry analyzer that is depicted here below. And these are the type of chemistry analyzers that peripheral labs often use to test UNEs and other routine clinical lab work. The results of the study were that we were successfully able to validate and implement these assays. We validated them to several reference tests in collaboration with in a reference laboratory in Nijmegen in the Netherlands for qualitative detection. And we were able to establish low qualitative cutoffs for the different compounds. I won't bore you with the cutoffs, but the important takeaway is that test performance around these cutoffs is very good. And importantly, what we were able to do in the clinic is that we were able to implement these tests in point of care. So what we did is that we took blood from patients who had a previous viral load above 1,000 at their clinic visits and managed to do the test and report the result back to the patient within a turnaround time of 45 minutes. This sort of clinical implementation where we try to use drug level testing as a point of care test is what we've now set out to continue doing in the 8Mar trial that is currently still ongoing at Ndlovu Care Group, where basically what we're doing is that in case a patient comes back with a high viral load, we perform this drug level test as point of care. We get the result back. If the drug is detected in the sample, we repeat a viral load and decide based on that viral load whether we should also do a drug resistance test. But if the drug is not detected, then we don't do any additional lab work. We give feedback of the level result to the clinician and the patient so that drug level informed adherence counseling can be performed. If we want to start performing adherence counseling based on the results of a negative drug level test, we kind of need to understand what a negative drug level test means in terms of adherence. And in order to do this, we did some population PK simulation work, again in collaboration with the Radboud University in Nijmegen. And this work was published recently in JADES. For the same 3 compounds that we implemented immunoassays for, efavirenz, lopinavir, and dolutegravir, we took a virtual population of 2,000 individuals, modeled them to have perfect adherence to the treatment, and then let them suddenly stop this treatment, and then measured the drug washout over hours depicted below to model how long it would take for them to convert to becoming drug exposure negative on our test. And what we found is very interesting and obviously heavily influenced by the PK characteristic of the different drugs. And of note, efavirenz displayed on the left, which has a very long half-life, showed not to be very amenable to drug level testing, because what happened is that it took very long for patients after stopping the drug to become drug level test negative, over 5 days on average. And the spread by which patients would become negative on the drug level test was very wide. Probably owing to genetic polymorphisms in how patients clear or metabolize efavirenz. For lopinavir, however, we saw that this drug is actually way more amenable to this type of monitoring. What we found is that lopinavir levels drop precipitously in plasma after stopping of treatment and become undetectable after approximately a day on average. When we looked at dolutegravir on the right, dolutegravir, which has a somewhat longer half-life of about 16 hours, took a little bit longer to become undetectable, but still performed quite well. And a negative dolutegravir level on average would reflect patients being non-adherent to about 4 days on average. Then I'd like to close by just talking about some new developments. And this is work that is mainly still ongoing and is involved mainly done by other researchers, but this is work that I'm very, very interested in. People have recently started exploring methods for tenofovir urine testing. And tenofovir, as you all know, is the active metabolite of the prodrugs TDF and TEF. And TDF and TEF are obviously predominant NRTIs, widely used in ART and also in PrEP. And the interesting thing about tenofovir is that it's renally cleared, and that, as you can see on the graph on the right, with urine tenofovir levels on the y-axis and plasma levels on the x-axis, is that plasma and urine levels of tenofovir are nicely correlated, but urine levels are way, way higher because of its renal clearance and are amenable to easy detection. Tenofovir urine testing was therefore originally developed in the context of PrEP adherence. It is obviously difficult to check for the adherence of a patient who is on PrEP, because you can't look at patients' viral loads because hopefully they'll be uninfected. So what people did, and this was work done by Monica Gandhi at UCLA and Giffen Daughtridge et al. At Harvard University, is to develop urine tests to measure tenofovir levels over time to check for the adherence of patients to their PrEP. Initially, they developed several lab-based ELISA assays, but over time, it proved possible to adapt these tests to rapid tests, as you can see displayed on the right, that had a very nice performance when compared to reference testing that allow for measurement of tenofovir levels in urine within 15 minutes. And multiple of these sort of pregnancy test type assays are now in investigational use and being rolled out to several research sites in the African region. And I've also started being in clinical use of PrEP clinics across the US. This is data from some of those PrEP clinics in the US. Investigators from UCLA again did similarly to us when we looked at the washout of different drugs in plasma, is that they looked at how long it would take to develop an undetectable urine tenofovir level if you would stop taking your tenofovir-based treatment, either TDF or TEF. And what these investigators found is that very similar to our previous findings for dolutegravir, if patients stop taking their PrEP for about 4 days, their tenofovir level becomes undetectable in the urine. And what they did is, and this is very interesting, is that they gave people their different regimens of taking the treatment, reflecting perfect and moderate and low adherence, and actually showed that the drug washout is actually not that dependent on previous adherence and nicely correlates to the last time you took a dose. So just to close off, several projects are ongoing that are all exploring different ways to implement drug level testing in monitoring of ART. What we are doing is that in the previously mentioned 8Mar trial in the POPO, we strive to use drug level testing in clinical practice in a single clinic visit to give patients who are failing ART feedback on their adherence. Investigators from the revamped study group, which is active in KZN and in Uganda, are doing a similar thing in patients on dolutegravir. Another project that the people at NHLS and Ezincha, headed by Francois Venter in Johannesburg, is embarked on is to simply take patients whose viral load results have been sent to the lab and where viral load has been found to be above 1,000 for reflex lab-based drug level testing on the same sample, basically giving you a reflex test much like, for instance, CLET after a low CD4. In case a viral load is above 1,000, a drug level test is automatically performed to see if drug can be detected so that the clinician can subsequently decide or better interpret the high viral load result. And lastly, what we've also started doing is that in the advanced randomized clinical trial, a large clinical trial led by Francois Venter from Ezincha, we've taken patients' urine levels. These are about 1,000 patients enrolled in this trial, 2/3 of whom are on dolutegravir-based regimens. And we started looking at their urine tenofovir levels to see if we can correlate outcomes on dolutegravir-based treatment to tenofovir levels in the urine. So I'd just like to conclude from everything that I've been discussing, and sorry if everything went so quickly. Virological suppression in the sub-Saharan African setting, and particularly in the South African setting, is very high. But unfortunately, there is a significant proportion of patients with a high viral load who remain viremic for a prolonged amount of time because the clinical action in response to their high viral load is delayed. At the same time, dolutegravir is changing the way that we will monitor HIV treatment, and our old paradigms for measuring a viral load and then empiric switching to another regimen do not apply much longer. Because of the obvious drawbacks of drug resistance testing, we feel that drug exposure testing might be an interesting new way of assessing the cause of somebody's virological failure after rebound, particularly in patients who are on high genetic barrier ART, either with dolutegravir or lopinavir. And hopefully in future, drug level or exposure testing can be applied in a variety of clinical settings and on multiple sample types. I'd like to acknowledge a few people. I've been very blessed and honored to be able to do my PhD with an amazing group of collaborators. And for the work that I've presented to you now, I'd in particular like to thank my co-promoters, as they are called in the Netherlands, Annemarie Wensing and Monique Nijhuis of the UMC Utrecht. The people at Ndlovu Care Group, Hugo Tempelman and Shijoke Umunakwe, Francois Venter and Samantha Lala Edwards from Ezincha in Joburg. My PK heroes, David Burger and Rob Terheine from the Radboud UMC in Nijmegen in the Netherlands. Sergio Carmona and Kim Steger from the NHLS. And the various participants and clinical staff at the different clinical sites that I've worked with while embarking on these research projects. Thank you very much for your attention, and I'd like to take any questions if there are some. Thank you.
Lucas, thanks very much for a really outstanding talk. I mean, I thought that was beautifully delivered and really just, very, very clear. So thank you very much. We do have some questions coming. If the questioners could put their screen on when asking questions, that would be fantastic. Lucas, can I just ask you first, though, you've obviously shown that this pretty much moment in time level really does correlate well with whether you should be doing a resistance test. How does it work versus the sort of longer term hair test? The sort of, my understanding, the HbA1c type test, is that actually better, or if they were combined, does it give even better differentiation?
So yeah, thanks, Prof. I think it's a very interesting question, and it is something that's been explored. One of the studies that I very briefly mentioned, I think led by Gert van Zyl, measured lopinavir hair levels and correlated that to drug resistance as well. And hair levels are obviously a marker of longer term adherence. And I think the main issue with those markers, I think, is that obviously testing is more cumbersome. Also, many people don't have hair, which is a problem when you want to measure those levels. But also what we were more interested in was just the very recent adherence, which is why we chose the plasma level, because we know lopinavir gets eliminated so quickly. We thought it would be a nice reflection of short-term adherence. In the PrEP field, there has also been a lot of work in intracellular NRTI levels, triphosphate levels, the NRTI levels that are correlated with longer-term adherence as well, which definitely shows strong correlations with adherence and outcomes. But I'm not actually sure if there's been any research in whether they can be used diagnostically. I do know that they correlate.
Thanks very much. So I've got Gary and then Graham.
Hi, Lucas. Thanks for a great talk. This is music to my ears. We've been chipping away at this in a small scale way for a long time. Just to respond quickly to Mark's question, hair concentrations are not only logistically difficult, but very expensive. You're not going to be able to get a dipsticks out of hair. The tenofovir diphosphate assay that Lucas mentioned is the gold standard for short to medium term adherence, but it's very expensive. I think Lucas, just one comment, it's all very well modeling the different therapy you need to be before you have an undetectable assay, but at the end of the day, it's got to be crude and simple. It's got to be, is it detectable, yes or no? If it's not detectable, then you don't proceed with a viral load or you don't proceed with a resistance test. So I don't think that modeling is going to help you a lot. And efavirenz is going to take longer to disappear than dolutegravir. But at the end of the day, I think that a simple yes or no answer is what's required. We were thinking with Gert in that paper of putting drug resistance, of drug assay in the lab when they were requesting a resistance test, because that's very expensive. But it's a moot point as to whether it's cheaper than doing the viral load. Although with these newer dipsticks assays, that probably is a very interesting way to go. But I think as a gatekeeper for resistance testing is probably where it could realistically be implemented, although I certainly think it's an interesting research question to do it as a gatekeeper for viral load.
Thanks, Prof. Yeah, I'd just like to respond to that because I think we had very similar trains of thought. When we had the immunoassays, we were also thinking these immunoassays, which are likely to be costed somewhat cheaper than viral loads, but still in that sort of same price bracket, it probably makes sense as a gatekeeper to drug resistance testing, because I actually did not show that, but obviously if half of patients have an undetectable level, that means you can just not do half of drug resistance tests and save the money. But now with the appearance of these tenofovir level tests, it sort of changes the scenario completely, as you're saying. The price range at which these tests are being priced is obviously not completely clear yet, but people are talking about them costing only several dollars, which really opens up, using them at a clinic level and then only sending a drug resistance off if you have demonstrated adherence on a dipstick and high viral loads. Thank you for the comments.
Thanks, Graham.
Thanks, Lucas. Excellent talk. I just want to go back to one of the first studies that you presented, where you had looked at the tier.net data and looked at that proportion that remained with a high viral load above 1,000 that sort of persisted at 10% between 1 and 6 years of follow-up. Do you know what the consequences for those patients were in terms of the mortality that was accruing in that patient group?
Thanks, Prof. Yes, we analyzed that and reported in the paper. I don't know the hazard ratios by heart anymore, unfortunately, but they had an increased risk of both mortality and loss to follow-up. We tended to use loss to follow-up as a surrogate outcome measure a lot in these studies, because we know a proportion of the loss to follow-up patients will have deceased, but will not have been captured as such. But documented mortality in tier.net was also correlated with a high viral load above it.
Yeah, I'm just interested in the proportion, because I think on a public health level, that kind of informs us about this switch to TLD. Because, if there are a lot of people that are in our system that are failing, first line and not being switched, is there public health merit about just getting all of those patients onto TLD? We know that the majority of them will do much better in terms of adherence on a once a tablet day, and in reality, they're not being switched to PIs anyway. I think that kind of data really does sort of push me towards thinking about, whether we shouldn't be trying to accelerate the switch to TLD across the board.
Yeah, I completely agree, Prof. I think the main word that I also took from that paper is that basically the same tendency that you see where it takes very long to switch. I think it's the same process that results in the transition to dolutegravir going so slowly, because also in the rural clinics, people are just kept on efavirenz-based ART and not relatively not switched regularly.
Yeah, and just making it so complex. You have to check the viral load and then make a decision. And if we just across the board switch to TLD, we might be doing a net benefit in terms of saving lives far in excess of any risks. It's just useful data to inform those discussions. Thanks.
Thanks, Graham. Pumla has put a question in the chat for you, Lucas. As tenofovir has a short half-life, is white coat adherence not an issue?
Yeah, this is a fascinating question, and it really has given me headaches, because what I worry about is that at some point we actually get to a point where we do this urine-based drug testing in the clinic, and then at some point, patients will just figure out that, well, similar to like diabetics, really, in order to get my glucose low when I arrive to clinic, I must just take my insulin several days beforehand. And yeah, I can only imagine that becomes an issue. I think, if we stick to a way of implementation close to what Prof. Martens was saying earlier, where you implement it as a gatekeeping test for drug resistance testing, then it might be less of an issue. But if you do it point of care and in view of the patient, then I can only imagine that at some point white coat adherence will start happening. Yeah.
Thanks very much. So just a final question. I mean, in your current studies where you're now using it to try and look at these 1,000, these patients who are slightly over 1,000, it says that if it's low, you're going to do an intervention, adherence intervention. How quickly are you going to repeat the drug level? And if the drug level's still low, as it's mental health month, what interventions would you do, which are you going to make to try and tease out whether lack of adherence is because of a mental health issue?
Yeah, thank you. I think that's what we embarked upon, and I didn't really have time to this at the local care group, is that we this adherence counseling is mainly given by lay counselors, particularly in rural clinics, and we try to sort of educate those counselors on A, interpreting a drug level test result, but then B, also kind of trying to find out what the underlying reasons would be if a drug level test was indeed low. Unfortunately, we don't have many results from that study yet, but I think the revamp study, which is ongoing in KZN and Uganda, does it at a larger scale and will probably give us some more data on how a drug level test will be clinically implemented. As to exactly how and when to repeat, I do not know. I think if you have like a tenofovir urine level, you could kind of advocate for just doing it at the beginning of a visit to see if your adherence intervention of the previous visit has made sense, and to only repeat a viral load once you've established that a urine level is at least present. Yeah, there's several issues with it. You're not obviously going to have a high viral load, do a urine level on month 0, do an adherence intervention, let the patient come back on month 1, do a tenofovir level detectable, then immediately send off a viral load, because the viral load will still be high if the virus is still decaying. So in short, I haven't really thought about how to time those things. And I definitely think that you should create an algorithm whereby if despite adherence interventions, patients are continuously drug level negative, then that is a grounds for further interventions or neuropsychiatric assessment or the likes.
Okay, I don't see any further hands up, and we're actually right on the hour. So, again, I really think that was beautifully presented, very logical, well taken, took us through this topic, which you're clearly very passionate about, which is fantastic, and, moving the field forward. So, really thank you, Lucas, for spending time with us today on that. And thank you to all colleagues who've joined. It's great to see a lot of clinical pharmacologists were on the call. So hopefully Lucas is around, and anybody who'd like to meet with him or discuss things, I'm sure he'd be delighted to have those meetings. So thanks again, and I wish everybody a very happy and safe weekend, and look forward to seeing you again. Thanks very much.